In this video, we'll do the integral of ln of x plus 1 over 2x. Also, don't forget to subscribe and turn on notifications so you don't miss a video. Okay, we're going to do this with the DI method, which is integration by parts. So we're going to differentiate something, we're going to integrate something. So we're going to integrate, so this term can be multiplied by 1, so we're going to integrate 1. So the integral of 1 is obviously x. Okay, we're going to take the derivative ln of x plus 1 over 2x, because we don't like natural log in the integral. So we have plus minus, that's what we have to do. Okay, the derivative ln of x plus 1 over 2x will be, so the inside will be on the bottom, so this will be x plus 1 over 2x, but don't forget to multiply by the derivative of the inside. The derivative of x plus 1 over 2x is 1 minus 1 over 2x squared. Okay, but we can do more than this. We can multiply, because the smallest on the bottom is 2x squared, we can multiply by 2x squared on both sides, both top and bottom. But what is 2x squared on the bottom? We can write that as 2x times x. And don't forget, this is an integral, so we have this times x dx. Okay, but before that, we have to do is this term, which is ln of x plus 1 over 2x, times this term, which is x. So this will be x times ln of x plus 1 over 2x. That's part of our answer. And then what we can do, because we have that, we can just do the integral. So we have this times this dx. So let's multiply 2x squared. So we're going to get minus the integral of 2x squared times 1, which is 2x squared, then minus 1 all over. So let's multiply 2x inside the fraction, which has a fraction, the term that has a fraction, so that'd be 2x times x, which is 2x squared, and then 2x times 1 over 2x, which is plus 1. But we also have an x term, and then we have an x term on the top, which can cancel. So this term will cancel, and we're left with dx. Okay. So let's get rid of the parentheses. Okay, so we want to have 2x squared plus 1 on the top to make this easier for ourselves. So we have 2x squared minus 1, but that's really 2x squared plus 1 minus 2, because 1 plus 2 is minus. Okay, we need to add, so we need to make this 1, and then we have minus 2, yeah. Okay, and then we need parentheses and everything, so dx. Okay, so we're going to have x times ln of x plus 1 over 2x, then we're going to minus the integral. So this over this, which is exactly the same thing, will be minus the integral of 1 dx. We can write the integral of dx as x, and then don't forget we have a minus sign. A minus sign means we have plus 2, the integral of whatever we have left, which is 1 over 2x squared plus 1, and dx. Okay, let's do this on the next page. The integral of 1 over 2x squared plus 1 dx. So we have to do trig sub, but let's make this easy for ourselves. So we want to have tangent squared theta plus 1, because that's secant squared theta, right? So let's make it that way. So the plus 1 we can kind of ignore right now. So we want 2x squared to be equal to tangent squared theta. Okay, now let's divide by 2. So we'll be left with x squared on the left-hand side. So now let's take the square root. We are choosing a substitution, so we can just we don't care about plus or minus. So this will be x equals, so the square root of tangent squared is tangent theta. We're choosing it to be, in this case. Okay, now we can differentiate both sides, which will be dx will be secant squared theta over square root of 2. Okay, and then d theta, of course. So this will be, so 1 over square root of 2 we can take on the outside. Integral of dx, which is this, which we did the 1 over square root of 2 already. So we're going to have secant squared theta. And on the bottom, we're going to have, so we picked x to be tangent theta over square root of 2. So we have that tangent squared theta plus 1 is secant squared theta. So on the bottom, we have secant squared theta, d theta. And it's the same term, so it's just the integral of 1 d theta, which is theta over square root of 2. But what is theta? Okay. So from this equation, you get that square root of 2 times x equals tangent theta, which means theta is the inverse tangent. So the inverse tangent of square root of 2 times x over the square root of 2. So now we can put that down. So we're going to have x ln of x plus 1 over 2x minus x plus 2, and then we're going to have 2 over square root of 2. Well, let's look at that. We can multiply by square root of 2 on both sides. So square root of 2 times square root of 2 is 2, so this and this will cancel, leaving us with square root of 2 only. So we're going to have square root of 2 times the inverse tangent of the square root of 2 times x, and then finally we're going to have plus c, where we have room. And that is the end of the video. Hope you liked it, and thanks for watching.